Hi, this is Mrs. LaBarbara. This is AP Physics Chapter 7, Potential Energy and Energy Conservation, Video 5. Today's topic is energy diagram. The objectives are understand the energy diagram and be able to determine conservative force from energy diagram. Let's take a look. What's energy diagram? Energy diagram is a graph that used to show energy as a function of x. So let's think about a glider with a mass m that moves along the x-axis on an air track. In this case, the force equals to negative kx, and the potential energy equals 1/2 kx squared. If the elastic force of the spring is the only horizontal force acting on the glider, the total mechanical energy, E, will be constant, independent of x. So here is a diagram. Here is the situation of a glider going back and forth, and here is the energy diagram. So as you can see, energy diagram is kind of like a big U because U is never negative. And here, the brown line that's indicate total energy, kinetic and potential. So the other part, from the blue line to the brown line, that represent kinetic energy. And underneath the blue line to the horizontal axis, that is the energy of U. These two added together always equals to E. That is constant. So on a graph, the limits of motion are the points where U curves intersect the horizontal line, represent total mechanical energy. So that's it. Let's see. Interpret the energy diagram. So here is a hypothetical energy function. So this is energy diagram. On this diagram, there are a couple points. So these points indicate force equals to 0, actually, because the derivative equals to 0 as highest and lowest point on a curve. So let's see. If the total energy E is greater than E3, then E is greater than E3. That means if the object could be released from here, it's greater than E3, then what's going to happen to that object? The object is going to go over here, will escape past x4, will be escaped to x is greater than x4. If E total energy equals to E2 over here, that means at this point the object can have kinetic energy equals to 0, the total energy is just the potential energy. That's the amount of total energy. Then where is that object going to go? It's going to up to xd, up to here. Then it's going to come back. Change potential to kinetic and back and forth. Over here, all the energy is potential again. Then that's a maximum E total. Then it's going to back again. So that means the particle is going to be trapped between C and D, between this point and that point, cannot go beyond those 2 points. However, if total E equals to E1 over here, that means at that point, the potential energy equals to total energy, E1, and the kinetic energy equals to 0. If you release that particle at that point with kinetic energy equals to 0, that particle is just going to move from in between this, between XA and XB. Because this, at that point, the total energy equals to potential energy. It can't move further. Minimum possible energy is E naught. The particle is at rest at x equals to 1. It's just going to stay there. It cannot be lower than that. Let's take a look at this example. A conservative force has a potential energy function Ux, shown by the graph right over here to the right. A particle moving in one dimension under the influence of this force has kinetic energy of 1 joule when it is at a position x1. Which of the following is the correct statement about motion of the particle? So let's see, at this point, its kinetic energy is 1 and its potential energy is -2. So its total energy is -1. So total energy cannot be bigger than -1. So that means at this point, when it is -1, the object's kinetic energy equals to 0. Then it cannot go higher. So what object is going to do is going to oscillate, right? Become -1, -1, just keep going back and forth here. So what could be the choice? The choice would be it cannot reach either x0 or x2. So here is x0, here is x2, cannot reach those points. Okay, determine the force curve from potential energy curve. So here is potential energy curve we have seen before, right? And here's a force curve. We can determine this. How can we determine that? First, let's take a look at this point, the highest and lowest point, the minimum and the maximum point. Each point indicate your force equals to 0 because at that point, du over dx equals to 0. So at those points, F equals to 0. Next one, we basically have to figure out how can we find if x is positive or negative. Remember fx equals negative du dx. Well, du dx is just a slope. Negative means it's negative of the slope. So over here, since the slope is positive, so f has to be negative. So over here is kind of like a little bit constant over here. Then its decreases become 0. So from here to here, force is positive because force equals negative of the slope. Slope is negative, negative of negative becomes positive. Now here is another 0. Over here in between, the slope is positive. That means force has to be negative. As a matter of fact, over here, the force is the most negative. Then over here, between these two zeros, the slope is negative again. That means the force has to be positive. And over here, the slope is positive. That means the force has to be negative. So basically, you just draw a kind of shape. It doesn't have to be exactly, but you should have an idea if it's positive or negative, how big it is. And the bigger the slope, the bigger the force. Again, over here, you have the biggest slope, you have the biggest force. So over here, the slope is smaller, so your force is smaller. Over here, slope is a little bit bigger, so your force is a little bit bigger, but doesn't have to be exact. Let's take a look at this example. You're given the function of UR, trying to sketch FR. So remember FR, that is a negative of slope. First, let's find 0. So over here, that's a minimum. That is your 0 point. Over here, your slope is constant positive. That means your force is constant negative. So that's the force. Then from here to here, slope is positive, but you'll have approaching to 0. So there is a curve going that way. Then over here, your slope kind of big and kind of like constant over here. So basically the rest, you connect a line. Okay, let's take a look at this last question. Check your understanding. So here is a curve of fx versus x. The curve has a maximum at a point between x2 and x3, right over here. Which statement is correctly describes what happens to the particle when it is at that point? So at that point, we know fx has a maximum point. Is the particle acceleration equals to 0? No, because f is not 0, so acceleration cannot be 0. This particle has positive acceleration. Yes, because f is positive. But the magnitude of acceleration is less than at any other point between x2 and x3. That is wrong because at this point, force is maximum. Therefore, acceleration has to be positive maximum. So that's the answer to next one. That is answer 3. Answer 4 and 5 says acceleration is negative. It cannot be negative because the force is positive. That's it for today. Thanks for watching. See you next time.